Imagine a floating structure so colossal that it could eclipse the combined weight of 6 Nimitz-class aircraft carriers. What kind of engineering feat would that be? The Shell Prelude floating liquefied natural gas platform isn't just a marvel, it's a jaw-dropping giant of the ocean. At over 1,600 feet long and displacing a staggering 660,000 tons, the Shell Prelude surpasses even the most legendary maritime vessels in both scale and complexity. While iconic ships like the Titanic and the gargantuan cruise liners like the Icon of the Seas might capture the public's imagination, the Prelude redefines what's possible on water, standing as a testament to the boundaries of modern engineering. Unprecedented weight and dimensions. The Shell Prelude is a floating city, as well as a vessel measuring an incredible 1,601 feet in length, 243 feet in width, and 344 feet in height. Built with 260,000 tons of steel, when completely loaded, it moves about 660,000 tons. The Prelude's enormous size and weight are highlighted by the fact that its displacement is more than 6 times more than that of an aircraft carrier of the Nimitz class. The Prelude's immense size is essential to both its intended use and operating environment. It is made to endure the harsh circumstances seen in the Indian Ocean, particularly in the region known as Cyclone Alley, which is prone to cyclones. This calls for an enormously robust structure that can withstand extreme weather conditions without compromising its functionality, goal, and usability. Natural gas extraction and processing is the Prelude's main job. It functions as a floating platform for liquefied natural gas, a complex system built to carry out a number of essential functions. In the Prelude, natural gas is extracted from seabed wells and cooled to 162 degrees C, 260 degrees for processing and liquefaction. The gas is easier to transport and store as a result of this liquefaction. Off the coast of northwest Australia, the platform's placement was carefully considered to optimize efficiency. It is located close to the Shell Concerto and Prelude fields, which together have around 3 trillion cubic feet of gas that can be extracted. This closeness to significant gas sources reduces transportation distance and maximizes extraction efficiency. However, because of the area's well-known storm activity, working here also comes with difficulties that call for strong engineering solutions to guarantee operational stability. Engineering difficulties and their resolutions. Building the Shell Prelude was a massive project requiring creative thinking to overcome the many obstacles posed by its scale and operational conditions. The necessity to acquire and handle enormous amounts of natural gas in a place that was difficult for traditional land-based facilities to reach motivated the decision to construct such a vast platform. Planning and building. The Prelude's design emphasizes its twin use as a production facility and a weather-resistant floating building. Shell used cutting-edge engineering methods to do this. One of the few shipyards in the world equipped to handle a project of size was the Goji shipyard in South Korea, where the platform was built. For more than a year, starting in 2012, around 5,000 workers were engaged in the construction. The hull was put together piece by piece, while other vital parts were manufactured in different parts of the world and subsequently combined. The construction process was sped up by using a modular technique, which was like putting together the biggest Lego set ever, but it still took 5 years to complete and cost an estimated $17.5 billion. Storm resilience. The Prelude has to be very weatherproof because of its placement in Cyclone Alley. A central rotating turret that is attached to 16 steel piles, each measuring 235 feet in length and 18 feet in diameter, is what anchors it to the ocean below. By driving these piles far into the ocean floor, a solid platform foundation is created. Nearly 25,000 links of heavy-duty chain connect the turret and piles. Storm safety is ensured with just 8 chains. The extra protection provided by the remaining chains guarantees that the Prelude will be securely attached even in the worst of circumstances. Energy production and handling. The power generation system of the Prelude is yet another technical marvel. It makes use of the steam generated by 7 of the biggest boiler units now in service on ships. Every hour, each boiler produces 220 tons of steam at a high temperature and pressure. The platform's centrifugal compressors have a single casing, double-section, back-to-back design that minimizes length and weight and is made to withstand the harsh conditions of a Category 5 cyclone. To guarantee dependability, the compressors go through extensive displacement checks and stress assessments, moving and setting up. It was an enormous effort in and of itself to move the Prelude from South Korea to its operational location off the coast of Australia. A new chapter in the platform's operating existence began in July 2017, when it was floated out to sea. In order to prevent delays and guarantee a safe arrival, the trip required careful preparation and coordination because it involved sailing through potentially dangerous waters, operational difficulties, and emerging issues. After being deployed, the Prelude encountered a number of operational difficulties despite its sophisticated engineering. Although it started producing LNG in December 2018, there were many problems in the beginning. 2 gas leaks occurred on the platform by early 2020, and in February 2020, there was an electrical failure that forced a halt that lasted until January 2021. The majority of the workforce had to evacuate due to a fire that occurred in December 2021, which resulted in a total loss of electricity. Operations didn't resume until April 2022. There was an additional 11 weeks of downtime in 2022 as a result of additional industrial action. Most recently, in August 2023, process-related issues forced the Prelude to close once more. Operations began again in January 2024. These problems draw attention to the difficulties and dangers involved in running a platform this large and sophisticated technologically. Even with its sophisticated safety features, such as its massive chain anchoring system and storm-resistant design, the Prelude's operational issues highlight the inherent difficulty in operating and maintaining such a complex construction. Innovations in technology. Several state-of-the-art technologies are incorporated into the Prelude to improve its robustness and efficiency. The platform, for instance, uses high-capacity boilers and steam power, which reflects the most recent developments in energy management and generation. The platform's dedication to operating reliability in harsh environments is shown in the centrifugal compressors, which are designed to withstand adverse weather. Support structures and lifts. To support LNG exports, the Prelude uses 3 42-meter, 100-ton bollard pull infield support vessels. 4 dynamic flexible risers with high pressure and temperature are also used. They are made to withstand cyclonic events that occur once every 10,000 years. The chilling process that turns natural gas into liquid requires 50 million liters of cold water every hour, which these risers are able to extract from the ocean. At the back of the ship, 3 6,700 horsepower Rolls-Royce USL 455 azimuth thrusters are installed on the platform. The Prelude is able to stay moored to the seabed and retain its orientation with the aid of these thrusters. The turret itself, the biggest in the world, is 30 meters in diameter, 100 meters high, and weighs 11,000 tons. In difficult oceanic circumstances, the platform's stability and operation depend heavily on its size and design. The Shell Prelude is currently in operation and will carry out its goal of producing LNG for at least 25 years. Overcoming the early teething issues and demonstrating its dependability as a model for upcoming offshore LNG plants will be critical to its future success. Large-scale engineering projects are inherently unexpected, as the Prelude's trip serves as a reminder. Despite its astounding magnitude and technological improvements, although the Prelude was originally intended to serve as a prototype for a new generation of offshore FLNG platforms, the fact that no successors have been disclosed begs concerns about the viability of these large-scale undertakings. Future improvements in the subject will probably be influenced by how economically and technologically feasible it is to build comparable platforms. The Shell Prelude is the ultimate in floating LNG production technology and a remarkable feat of naval engineering. Its enormous size, intricate design, and cutting-edge technology characteristics highlight the aspirational objectives of contemporary offshore energy extraction. The Prelude is nevertheless a monument to human ingenuity and the unrelenting pursuit of invention in one of the harshest places on Earth, despite its operational difficulties and hefty expenses. It will be interesting to watch if the Prelude manages to hold on to its title of largest floating structure and how it affects offshore energy production going forward. What do you think of our video? Let me know in the comment section below. If you enjoyed this video and want to hear from me again, be sure to hit that subscribe button before you go. Thanks for watching.